Yeah, okay. So I'm going to talk briefly about hot code upgrades. How many people here build Elixir releases as part of their release process? So actually, let me ask the other question. How many people here ship Elixir? So everyone's here building releases. Okay, so hot code upgrades are like the +1 for releases. We rely, and Castle depends upon all the release infrastructure that's been built into Elixir, and then just makes a few tweaks so that it works reasonably smoothly. Okay. So by hot code upgrade, probably most people familiar with Elixir will know through its Erlang heritage that we're talking about the ability to upgrade a running system. That means that no state is lost. Sometimes it's transformed. Sometimes we actually upgrade the state of running parts of the system. But things like socket connections, OS resources, and so on, none of these are lost during the upgrade. Right? So it's not it's not wholly unique just to Elixir to be able to upgrade running software, but I think the extent to which it's built into the Erlang runtime system probably is unique. And the way we're going to briefly go through this today is we're going to view what I call, even in the Erlang literature, we call systems are just a sequence of releases. Okay, so basics in Castle, you add Castle as a dependency. You define your releases, and then you Castle brings for Castle in as a build time only dependency, and then you adjust the sort of customizable steps of the Elixir release process around the assemble task. And for Castle pre-assemble and post-assemble make the tweaks that are necessary to turn what I would call a vanilla Elixir release into essentially an upgradable release. They do a couple of things. And I'll talk about those briefly. Okay, how does it actually basically work? The Erlang virtual machine can load 2 versions of every module and holds this in right in the guts. It has a notion of the current version and the old version. When you call load, typically you're not actually calling this code. A lot of the infrastructure is calling it for you. Any code that was loaded at the start when you brought the system up, that becomes the old code. The loaded code becomes the current. People don't always realize this, but this will actually fail if there is already old code in the system. I'll just jump to the end here. So there's this notion of having to purge old code before you have to essentially free up that old slot before you can successfully load a new module in and let the existing module move into that old slot. Now, most of this is taken care for you if you follow sort of the release process, but that's a thing. Now, sort of orthogonal to the notion of the VM having 2 versions of every module, there's the notion of like what's running in a given process, and a new version of a module won't be loaded into a process unless you make what's called a fully qualified call to it. If that is not the module you're in, it's almost certainly a fully qualified call, because you have to fully qualify to make a call to another module. But for instance, if you were in a private function, tail recursing into that private function forever, for whatever reason, that would not be a fully qualified call, and you would not allow that module while it was running to be loaded again, because there's no fully qualified call back to itself. You'll run into issues if you have those kind of calls in your system. Long-running calls then don't make an external call back to themselves. We'll discuss mitigations for that in a minute. And then, yes, there's this notion of purging code, and it just kills any process that is lingering in that old code. We've been fully owned.
That one converted, not this one. They're
And
both
just a remote.
button on and that one. Oh. Just narrowcaster. Okay.
All right. Okay. Okay, fundamental library that you don't actually see much of unless you're doing hotcode upgrades is SASL, the System Architecture Support Library. It's one of those really sort of crufty old Erlang libraries. It's just like been around forever. Its APIs are all ugly, but they're sort of essential to building hotcode upgrades in a reasonable manner. Essentially, there are two modules that do things. There's systools, which is a build time thing, helps you prepare releases, checks that you're sort of operating within the bounds of sanity. And then there's that will produce you artifacts for shipping a hotcode upgradable artifact. And then release handler is how you get that running in an existing running system, how you move it. So release handler has a number of calls. And Castle actually wraps both of them. Okay, how do we take the version of our app? I'm not talking about a release here, but our app, typically our sort of mixed project. We use what are called Appup scripts to go from current version, well, to get an existing system to move to our shipping version. You can, it's essentially just a script of essentially Erlang terms or Elixir terms that describe the steps you want to take. People often ask whether or not this is something you can just generate, but it would require probably ChatGPT-5 would probably make a pretty decent attempt at it. Normally, you need to understand what's changing in your system and the dependencies that exist in that system in order to be able to build the script correctly. But there is, in the Erlang documentation, there's something called the Appup cookbook, and it just lists some examples of the sort of things you have to do there. Sometimes you're just literally swapping out a functional module. You're literally changing the implementation of a single function. You can just say to the virtual machine, load this one. Sometimes you're doing something more sophisticated. You might be upgrading, you might be changing the state of an existing process. You might be introducing a whole new supervision tree, or maybe even removing one. There are instructions to do all that, and you put them in your Appup script. Castle will take that at build time and place it in the right place. It's actually in the ebin directory of your application. Castle also lets you to write this script in Elixir terms, so it's just a little bit more familiar. And then as an author, it's your responsibility to ship that script with each version of your library. And what you're saying is, if my application is going to participate in a hotcode upgrade that you're doing, then you can apply this and it will upgrade correctly. If you look at some of the Erlang things like SSH and so on, if you're familiar with that, they have a default script which just says, "Oh, stop the app and then start it again," which is possibly a reasonable default, but it's not exactly. It's going to kill all the socket connections. So there's here's a really simple, here's about the simplest Appup. It's like the hello world of Appups. I'm saying I'm building version 0.1.1, and if I'm upgrading from 0.1.0, I want you to load this module from. That's the new version of the module. And if I'm downgrading to it, I want you to do this, in this case, the same thing. But typically, you can have lots more instructions within each one. And secondly, you can have lots of versions in here as well. So each time you ship your app up, you're saying, if I'm upgrading from this version, you need to do these steps. If I'm upgrading from this version, you only need to do these steps. And it's your responsibility as the app author to put this together and test it, which is why no one does it.
Just before you move on, was that a no-op?
No, because my app.my module could contain a bug fix for, say, a pure function.
Right.
It's doing something, I found a bug in it, there's a new version of it. Loading a module will then let processes that make calls to that module will get that after the VM has loaded it.
And when you're downgrading and you're loading it again with the same name, it knows that you mean the old version of it.
Yes, it means, so yes, it is like the nomenclature is confusing, but in the top example, it's saying when I'm upgrading from 010, load the one from where I want to move to,
Yeah.
and in the old one, load the one from that version.
I assume that before it runs the Appup script, it's changing the beans, right? That's why.
Yeah.
Yeah. Okay. Yeah. So it's pointing like when you downgrade, it's like, oh, I'm going to point to the old e-bean with the old modules, and I'll load it again.
Right.
Okay, and then for that sort of build time support of taking that Elixir script and then essentially just converts it into Erlang terms and moves it into the ibin folder. If you have Castle, you just set this Appup property in your script. You just say, where is my Appup script? In this case, in the root, and you add it to the set of Appup compilers, and it just happens as part of the process. Okay, relups.
Before you go on, there was a question online. It's about one module and not a full dependency, like X dependency.
You're responsible for writing the Appups that describe how to take the set of modules in your application to an equivalent state in the next version. So rather than stopping version 1, bringing the VM back up, starting version 2, how do I get all the code in place for version 2 and tell the virtual machine how to move to that state without taking any state down?
And you do it per package, per application.
Yeah. So, yeah, exactly. And then relups are, well, now you say in my day-to-day work, I have a mixed project where really the only thing I'm working on is the application in that mixed project. And I generally don't ship, I keep my dependencies stable, so I don't care that no one ships Appups for those dependencies. I ship Appups for my thing. When I build a release, that's the only Appup it's shipping, because every other dependency is pinned at exactly the same version. But I tell the system how to move the whole system, because it's only my application that's changing, how to move it. And a relup is essentially just a composition of all the applications in your release. It takes all their Appup scripts and puts them into a relup script or some other checking. It uses things like dependency ordering to work out which applications should happen at which time. The relup is nearly always automatically generated. It's not something you would write from hand like the Appup. It just is based off the sequence of Appups that are going to participate in the system upgrade. And you don't really want to make your eyes bleed to read it. It's pretty ugly. But when you have it, it is a release artifact. It lives in, if you're familiar with the structure of an Elixir release, it lives in the releases subdirectory. Castle actually provides a mixed task to help you generate a relup from one version to another. So to go from this version of my entire system to this version of my entire system, Castle will call the systools call, which will enumerate all the changing applications and compose the Appups. So this is pretty much the steps, and then this is how I do it. I check out and I build my release. I check out the next version, I build my release, and then I use this mixed task, which goes through the rel files that ship with every version, and it will generate this relup file. And this is where it also gets common. Now I have to rebuild version 2 again, because now I have my relup file. If I just ship my version 2 at the second stage, I don't have a relup. So I can ship it and you can start it and stop it, but you can't have the upgrade. You need the relup to do the upgrade. So that's what that mixed task does. So we rebuild it. And now we've got essentially, now I can do essentially mix release using the steps that the sort of for Castle pre-assemble, post-assemble steps. That will generate me an Elixir release. So assuming I've dropped it into, say, Optimi app, I've got version 1, it's already there. I'll take my version 2, I'll copy the output from the release, and I'll drop it into the releases subfolder. And then another thing Castle does is it adds these commands to the bin, effectively to the shell script we use to boot Elixir releases. It adds these like unpack, install, commit commands. And this is it. So what unpack does is it carefully takes apart your release file and it places all the new applications in the right place and the Appups and the relups and what have you. But it doesn't install it. It's there, and the system knows it's there, but it's not running. Install is the thing that runs the relup script and does all the magic. And commit is kind of interesting. So when you do an install, Elixir releases, Erlang releases, they exist in like 4 states. They're either, the common one is permanent, that's what will always be running. Permanent is you're running, essentially, normally you're running now, and you are the version, if the system restarts, that will be booted into. If you start doing hot code upgrades, you get this new state called current, which means I'm now running version 2, but if I crashed and restarted now, I go back to version 1. So commit makes the current version the permanent version. And it gives you an opportunity to go, that didn't work. I'm going to just call install again on the previous version and roll back. And so you can go up and down. Okay, demo. The clever trick is this whole thing has been a demo. This is a live view app. And when I hit next, I upgrade to the next system. The repo only has 1 slide. And when I hit previous, I downgrade to the old system. I don't know if we can even see it.
If you jump multiple versions, does it sort of compose that for you?
No, so you have to compose that in your script.
Right.
So let me just have a look here. I don't know how easily this will be.
Do you have a Gunn server that stores the slides or something?
It's a live view process, and what my script actually does is it upgrades the live view module. It has the render in it, and then the scripts you can also put generic apply calls in scripts, and I just do a pub sub, and I tell the system, hey, there's a new version installed, and it just sort of
Calls render
navigates to itself again.
Okay.
Cheating a bit. Let's just have a look here. I don't know where I install this.
Hey, Nick, if you're showing code, you might need to reshare your screen.
Okay, one sec.
We're still on the browser.
Okay, let's try again.
I was going to say that's the best excuse for having plain looking slides I've ever heard.
Oh, it keeps going back to, oh, I shared the wrong thing. Hang on a sec. Let me try. Which one is it? It's a really big one. Is it this one? Okay. Oh, you can see, yeah, where it's going through that.
I need to get a picture of this.
We can see where you went back as well.
Yeah. So I guess it doesn't actually. It says share the screen, but it's not really showing the screen. It's showing the window.
You can share the whole thing.
Can you?
Yeah, just click on that. Just desktop one.
Oh, click on. I'm an idiot. Okay, so if we see this is the release I built, I can do, this is another command, so I can see all the releases that are in the system. You can see that like I went back a slide, and so 12 is the current version. I can probably go, is that right? Let's have a look. Oh yeah, maybe. Oh no, it's because I've pre-installed all these things just to make life easier for me alone. And so in principle,
But
I can.
If you migrate to another version, the slides should automatically update.
Yeah, I'm going to go to the last one in this case. Here we go. What could possibly go wrong? So
Very little.
I'm going to install 13. Okay. There we go. That's all you get.
So you were talking about upgrading individual apps, or so an Appup that can do multiple modules in those steps, right? Is there some sort of transactional arrangement where you can know that all the processes running those modules have finished their reductions and now they're upgrading for the next reduction, or?
You are essentially going to give an opportunity for the system to come in normally when you just make an external call on that module.
Right.
Normally, if you're just, and this is why it's always a good idea to stick to like OTP-based things, is because they're always calling into your behavior module externally, and that's an opportunity for them. Also, there is support like for the hot code upgrade, so there are system messages flying around that do this, and additionally there are some instructions which are called synchronized code replacement, and what they will do is, for instance, they will look for all the processes running a module. This is also why it's important to use supervision trees, because supervision trees are traversed to find the processes that are running modules. They'll find them, they'll stop them all, they'll switch the code out, and then they'll start them all again. But so there are instructions there to do that, and for the details you'd have to look in the Erlang documentation.
Sure.
Yeah, so like the Gunn server has like a code change callback, and that's exactly what does it. It says, it tells the Gunn server, so it suspends, say you're no longer getting messages from your inbox. Then it goes through the code change callback, and then it resumes. So it starts processing the inbox again, and that also has implications that you have to consider, because, well, you may have suspended the process from processing the inbox, but it may still have old messages from the old system in the inbox. So you have to be careful, because you cannot say, oh, I'm just getting those new messages. You may still have to go through the old messages, so you have to be careful with how you write those processes.
Yeah, so in my mind, I was comparing this to database migration.
Exactly.
This is worse, right? Because they could be in flight.
Yeah, it's like don't rename our database columns, right? So apply this to structs, messages, right? You have to be careful.
Yes, it's not, in my experience, like it isn't straightforward. I actually think that in terms of like what you get out of the box within an Elixir release, it's actually not very far from what you need, what that would need to also support hot code upgrades. One of the big differences is when you want to operate in a hot code upgrade environment, there is only one configuration file that is allowed in the Erlang virtual machines. You normally don't see this. You just go, I just write like config dev.axs or prod.axs. But essentially, what an upgradable virtual machine expects is that by the time it starts, all that configuration, even if it was captured at runtime, is written into a file called sys.config. It has to be in that file because, and when you do an upgrade, one of the things Castle does at runtime in the upgrade is regenerate that sys.config, because the runtime system expects to compare them. And you'll see this callback in Phoenix applications where there's a sort of config change callback. That is called, that's not something that the Phoenix guys invented. That exists because when you do a hot code upgrade and config has also changed as well as code, it will tell you, this is what's changed, this is what's added, this is what's been removed from config. One of the things Castle does is ensure that that sys.config is generated either from your runtime.axs or if you have config providers from those as well. That was actually the biggest thing that was needed. And what it means is that when you actually do start and stop a system, and this is common to the way old Erlang things like Relics used to do it, is you actually have to start the system, bring it up, generate the config, the sys.config, bring it down, and then bring the actual system up. So you have that overhead for system start, but I think for servers, that's not really relevant for long-running servers. But it is the crux of why, like, I needed Castle to make these changes and for Castle to make the builds changes. But other than that, most of it is just there, and then the rest of it was just support around the shell file. Anyway, there you go.
That's great.
All right, I'm stopping sharing.
So I have a more general question about hot code uploading, because that was one of the things that was most exciting about sort of early Elixir to me, and I'm sure we talked about it, but very few people actually ever did it. Why do we think that is? Is it really that hard? How does Castle
So my experience
take the
is
friction away?
if people are already in working deployment patterns, and there's an awful lot of infrastructure around, draining connections, running multiple instances, failing over. There's just tons of that, and there's also a ton of infrastructure experience about it. And I think if you have a kind of DevOps culture where, I would say more ops than dev, like it's a tough thing to tell people, I'll go and learn about the way these guys in Sweden 40 years ago decided to do hot code upgrades, when they go, oh no, I can just do these things with Kubernetes or something. So I don't think you're ever going to sell. Like in my environment, there's very few of us. We have got it kind of into our development cycle. It's something I was like daily shipping releases in this pattern, and you get used to it. The workflow is not as easy, but it's just a pattern you get into. But I think if you've got existing infrastructure and existing techniques, then I don't know why you would opt for this. It is more complicated.
But you didn't drop your WebSocket that whole time, right?
No, I didn't. It's still running. So, yeah. So I mean, there are scenarios where people aren't running in these Kubernetes-like environments where dropping connections is critical. Telecoms is one of them. It can cost them a lot of money to do that. So they put a lot of effort into it, but yeah, it's more effort than not doing it for sure.
Jose, what was your take on that? I mean, have you seen many people really do hot code upgrading?
If people do hot code upgrading, no, I think, no. And I think it's partly like chicken and egg issue, like before Castle. I don't think we had tooling. I know some people use the tooling in Distillery before for doing that, but yeah. Oh, is it because we are? Can they hear us? Do they hear us?
Oh yeah, but that's us.
Oh wait, it's here. It's not there. But before the camera was there.
All right, I might get back off it. Yeah. Thank you, Nick. That was great.
Yeah.
Are there any? Were there any other questions online?
I think you might have covered it. We had a question around how does the full release hot code upgrading compare to what Phoenix does in dev mode with the live code reloading?
I would say that live code reloading is just sort of lucky chaos.
Yeah.
It works for what you're doing in dev at the time, and if it doesn't, you can just hit refresh.
Yeah. So all that Phoenix does is it only does it only loads the new versions of the modules. That's all. So there's like no state upgrade. So you can actually try this out. Like if you have a process in your supervision tree in Phoenix, and then it's running, right? Like we start the app, that process is running, you change the code, and then of that module, and then you're upgrading the code, but you're not really upgrading the module, right? So and then you change again, you may see like the process getting crashing because you updated the code too many times without restarting the process. Or if you like, so imagine you have like a June server and a supervision tree in a Phoenix app, and then you go and change, you rename a struct field, which is going to be a crash for sure, right? Because we are only upgrading the code, we are not restarting supervision trees nor anything, then that process is going to crash, right? But we don't care, it's dev, right? It's going to crash, it's going to restart, everything's going to work again, and yeah, this chaos, as I said, is completely fine for dev. Yeah.
Thanks for that. And a bit of a shout out to a package called the Mishka installer from one of the online attendees. Maybe that's worthy of a meetup talk itself, Sharia, if you'd like to submit an issue on our Elixir Sydney GitHub, we could have you on to talk more about that in depth. But I think that's it from the online crowd.
I had one more question from here. When you said you were sort of upgrading and you kept all the dependencies as they were, is it problematic in your case to, when you want to do dependency upgrades, to just make it easy on yourself, you just do one big batch of dependency updates?
If I do a dependency upgrade, if I'm going to do one, I'll do them all.
Yep.
I'll even do like a VM upgrade. I mean, we didn't discuss this. I don't want to get into it. You can even do upgrade Ertz itself, but that will stop and restart typically under Heart, which is also pretty old and crufty. If I'm decide to upgrade dependencies, I'll upgrade everything, and I'll just do I will wear the restart. But that's much less frequent for me than updating the code that I'm working on. I don't really, most of the things that come through on dependencies, unless they were like a security issue, I don't really care, So, and if in a pinch I really wanted to, I could write. There's nothing to stop me writing the Appup for someone else's package myself. I think I'm considering like a sort of buy me a coffee, trying to fund a buy me a coffee lifestyle where app authors can send me their apps and I'll write the app.
That's a pretty good service.
Until ChatGPT 5
Yes.
is doing it for me.
So when you have to, so if a dependency doesn't have an Appup, then you have, and you want to upgrade it, is your only option like to stop and start it again? Or you can
No, I could like if there is no Appup and I don't want to write one, I'm stuffed. The only option then is to restart the whole thing. If I wanted a default Appup, I could say my default Appup is that application is going to start and stop again, and maybe I can wear the impact that's going to have on my users. Because it's simple to write an Appup. There literally is an instruction that says stop application and start application.
But if you stop an application and it's your dependency, you have to stop as well, right? Or no?
No.
Oh, they allow you to stop.
I think it'll stop without it. I think it'll stop without stopping you.
Okay. But yeah.
How do you compose them from the package? Do you need to explicitly say in the next deployment that you need to bring that up with your app?
So is this for a third-party dependency?
If you upgrade Phoenix, let's say, right, as a dependency, and you have your code upgrade, do you need to manually compose and reference that, or Castle just fix that?
I would need to make sure that in the release that I prepared, any Appup I'd written for a third-party dependency was in the correct folder for that. So and then I would need to generate the relup.
Relup picks up everything that is in the bin.
So yeah, essentially what the relup will do is look at the release file, which is always generated for an Elixir release. It contains the list of all the versioned applications that are in that release. It will walk them, work out the differences, and then consult if it's a brand new app, it will just say, start this app. If there are two existing apps, it will say, okay, find the Appup for this, and then find the version in the Appup, what version extract the instructions and insert them into the relup.
So Appup is per application, not per system.
Correct. The rel-up is for the system, the Appup is per application.
I also checked the README. When do you need the castle in the runtime? I couldn't really get that.
So you need Castle only in the runtime if you're releasing a system. If you are simply generating an Appup, you can have Castle as a build time dependency. Castle is only used as a front end into those extra commands you saw hanging off the shell script. It's a single module, but you only need it if you are actually, if the target, if you're building the target system. If you're just building an app and distributing the app as a library in Hex or whatever, then you can ship the app up in that, and you won't have any code from Castle or for Castle in there.
When you press the keyboard to change the slide, was that doing a command line? Was that
No.
calling something in the shell, or is there an API
There's
also
an
that you
API.
can call
I'm calling
programmatically?
Castle API from
Okay.
inside the code. Yeah.
Got a question. When you're doing this thing, I'm thinking about things like Observer, so you can sort of see all your process and that kind of thing. Is there something that you're looking at when you do it? Like, might be a tense moment. Like, is it going to work? Am I going to commit this? Is something? Are you just looking at like the logs of like it's doing that now? That app is that version, that kind of thing, or?
So in the apps, I normally have all my sort of most of my stuff is web apps, and I normally have the version of the system sitting in the top left-hand corner, and I make sure that, so like I'm doing it at the command line, so I can see if it's worked or not. And normally, if it says it's worked, it's worked.
Right.
There might be a bug in the script which means it didn't have the intended effect I wanted, but the script ran. And that's again another part of the burden of the life cycle is that you have to take an existing UAT system, apply an upgrade to it, go, oh, I think maybe that didn't work, ship, like that, develop, write the script again, fix some bugs, ship, upgrade again. So your upgrading becomes part of your dev cycle.
Right.
It's not a great way to put a slide deck together.
It had the desired effect though.
Yeah.
Awesome. Thanks, Nick. I think that's all the question time we've got. So thank you very much.